Good evening and welcome to NPTEL classes. Today I am here to solve chemistry class 11th NCERT problem 2.34 from unit 2nd, that is structure of atom. Let me read the problem. Calculate the energy required for the process unipositive gaseous helium ion changing to dipositive gaseous helium ion involving loss of one electron. The ionization energy for the hydrogen atom in the ground state is 2.18 into 10 raised power minus 18 joules. So after this read, I got to know that I have to calculate ionization energy for ionization process involving conversion of unipositive gaseous helium ion to dipositive gaseous helium ion involving loss of one electron. Process is ionization process involving loss of one electron from unipositive gaseous helium ion resulting in formation of dipositive gaseous helium ion. For this, in order to bring this change, in order to bring this ionization, I need to calculate how much energy is required. That energy is called ionization energy. What is given? Given is helping statement is that ionization energy for the hydrogen atom in ground state is 2.18 into 10 raised power minus 18 joules. In fact, per atom, joule per atom. For one atom of hydrogen, ionization energy is 2.18 into 10 raised power minus 18 joules in its ground state. And it means if electron is present in n is equal to 1 of hydrogen, and now we show interest to remove this electron from n is equal to 1 from first orbit of hydrogen to an infinite orbit where it will not experience nuclear attraction. Energy required in joules is 2.18 into 10 raised power minus 18 joules. This problem is based on Bohr's model of hydrogen atom. In Bohr's model of hydrogen atom, when we do calculations to determine the energy of an electron in orbit, we find that energy of an electron, expression for energy of an electron is minus 2.18 into 10 raised power minus 18 Z square by n square in joules. Let me write this expression. Expression is E is equal energy of electron in nth orbit of hydrogen atom is equal to minus 2.18 into 10 to the power minus 18 Z square divided by n square, and this value is in joules. Now for ionization, from nth orbit, suppose electron is present in nth orbit and can take any value in 1, n is equal to 1, n is equal to 2, n is equal to 3 likewise. We suppose electron is present in nth orbit and from this nth orbit we are interested to remove this electron to infinite orbit. Ionization means to take electron from any orbit of atom to infinite position, infinite orbit where it does not experience nuclear attraction, and energy required will be, ionization energy required will be, ionization energy required will be, energy difference will be equal to difference in energy between an energy of electron in infinite orbit and energy of electron in nth orbit. Energy of electron in, using this expression, on base of this expression, energy of electron in infinite orbit, if I will substitute value of n equal to infinity, this whole will become equal to 0. It is equal to 0 minus energy of electron in nth orbit is minus 2.18 into 10 to the power minus 18 z square divided by n square, and it is in joules. Ionization energy, in order to cause ionization from nth orbit in an atom, is equal to 2 point, this story is for hydrogen atom, 2 point minus minus will become plus 2.18 into 10 to the power minus 18 z square divided by n square, and this value will come in joules. This value will come in joules. For hydrogen atom, Z is 1, and since it is given ionization energy of hydrogen atom in ground state, if we will, for hydrogen atom in ground state, we need to substitute Z1 and N1, it will become, ionization energy will come 2.18 into 10 raised to power minus 18. That is why in the question ionization energy of hydrogen atom in ground state is given, and it is calculated actually from this equation which comes from Bohr's model of atom, Bohr's model of hydrogen atom. This equation is based on hydrogen atom, or we can apply it for any one electron system having Z equal to 1 or greater than 1, but number of electrons should be equal to 1 only. Now if I apply this equation here for this process, if I apply this equation here for this process, what I need to know? I need to know from which orbit I have to take electron out from this unipositive helium ion. Helium has 2 electrons. Helium atom has 2 electrons. And in unipositive helium ion, there is only 1 electron because 1 is already removed during first ionization. Now left is 1 electron, and this electron is present in n is equal to 1, first orbit. Electron, let me write here, electron, this electron which is to be removed, electron to be removed is present in, electron to be removed is present in first orbit. First orbit of helium ion, unipositive helium ion. That is, we have to effect ionization from n is equal to 1. this electron now at infinity, is, or I may write, was present in first orbit n is equal to 1. So I now got the idea that ionization is occurring from first orbit. Let me write, for ionization from first orbit, I need to substitute n is equal to 1. Let me write here, for ionization from first orbit means I have to substitute n equal to 1. Ionization energy, on base of this equation, ionization energy will be equal to 2.18 into 10 to the power minus 18. N is 1, 1 square is 1, so I will get this equation. In fact, this is the applied form of equation which I need to use here, that ionization energy, to bring this ionization process to remove an electron from first orbit of unipositive helium ion to form dipositive helium ion, will be calculated using this equation, and is equal to 2.18 into 10 raised to power minus 18 into Z square. So value is basically, that value is same as ionization energy of hydrogen atom in ground state, but here multiplying factor, here overall value will change because of presence of this multiplying factor here. For hydrogen it was 1 square, but here for helium it is 2 square because atomic number of helium is 2. So let me write here, for helium atom, Z is equal to 2. And if I will substitute here, ionization energy will come 2.18 into 10 to the power minus 18 multiplied by 2 square, which is equal to 4, and energy, ionization energy, will become 8.72 into 10 to the power minus 18 joules. This is our answer. This is solution to this problem. So what we learn from here, we could learn that for this ionization process, and what is the ionization process? First, let us recognize what is ionization process. For removal of one electron from first orbit of unipositive helium ion to form for removal of one electron from first orbit of unipositive helium ion so as to form dipositive helium ion, energy required is equal to 8.72 into 10 raised to power minus 18 joules, or energy required is 4 times greater than ionization energy of hydrogen atom in ground state. And this all is difference between hydrogen and helium is because of difference in atomic number. Here atomic number of helium ion is 2, and for hydrogen atom atomic number is 1. And for that, in order to solve this problem, first we needed the idea where from which orbit ionization is occurring. Ionization, and idea we have that ionization in case of unipositive helium and is occurring from first orbit. So here in this equation, which expresses ionization energy from nth orbit of hydrogen atom, we substituted value of n equal to 1 and we got ionization energy to effect ionization from first orbit of helium ion will be equal to this substituted value of Z equal to 4. We got this value, which is 4 times that of hydrogen. Class 11 students, this is what I have got for you today. In fact, this is very important problem because in Bohr's model of atom you only learn to calculate energies of electron in various orbits of one electron species, mainly hydrogen atom. But you should also be able to calculate ionization energy required. You should also be able to calculate ionization energy, that is energy required to effect an ionization. That is energy required to remove an electron from any orbit of hydrogen atom or any one electron species like unipositive helium ion or dipositive lithium ion. Take good care of your health. See you day after tomorrow. In fact, see you on Monday because tomorrow is turn of class 12 students and day after tomorrow is Saturday. Take good care of yourself. Allah Hafiz.